This video is for Homework and Mastery 4.2, Section 13.2 in your textbook, Factoring by Grouping. What we're going to do here is look at how we can group terms together to factor in the polynomial. So for example, we looked at this one earlier, 6 times 3x plus y minus z times 3x plus y. Notice we can factor out the entire binomial 3x plus y. When we do so, 3x plus y is the common factor, and I'll be left with 6 minus z in my second set of parentheses, which are my leftovers. This procedure is called factor by grouping because I have grouped two terms together and I've factored those out. Where I look at x squared plus 7x plus 3x plus 21, I don't want to combine my like terms. I actually want to leave them the way they are. I want to look at my first two set terms and factor out what's common there, and then look at my second two terms and factor out what's common there. Notice in my first two terms, my common factor is an x. In my second two terms, my common factor is a 3. So if I factor out an x from my first two terms, I'll have 7 times x squared, I'll have x times x plus 7. If I factor out a 3 from my second set of terms, I'll have 3 times x plus 7. And this is what it will look like, because I have factored out an x from the first two terms, and I have factored out a 3 from my second set of terms. Notice, now my sets of parentheses are the exact same, x plus 7. They now become my common factor, and I can factor out an x plus 7 and have x plus 3 left over. This is considered factor by grouping. You can always check yourself by doing the FOIL or multiplying distributive property. X times x gives you gives you x squared. X times 7 gives you 7x, 3 times x gives you 3x, and 3 times 7 gives you 21, which is what we started with. Let's look at 2x squared plus 3x plus 6x plus 9. Again, I want to factor by grouping. I want to look at the first two terms and factor those, and then look at the second two terms and factor them. Out of the first two terms, the 2x squared plus 3x, the only thing I have in common is an x, so my factor will be an x. Out of 6x plus 9, my common factor will be a 3, because I can divide the 6 and the 9 by a 3. When I do this, from my first sets of terms, I will have x times 2x plus 3, and my second set of terms, I should have factored out a 3 and have 2x plus 3. Now, notice my sets of parentheses are the same, 2x plus 3 and 2x plus 3. I can factor those out and put my leftovers in the other set of parentheses, and gives me x plus 3. Remember to always check yourself. Here I have 4x plus 8y plus 8x plus 2ay. I can still look at my first two terms and factor, and look at my second two terms and factor there. Out of my first two terms, I can factor out a 4. Out of my second terms, I can factor out an a, because there's an a in common. When I do so, out of my first terms, factoring out a 4, I will be left with x plus 2y, as shown here. Out of my second terms, whenever I factor out an a, I'll be left with x plus 2y, as shown here. Notice, again, my parentheses look exactly the same, which is the way I want them, because now then, my common term is x plus 2a. I can factor out the x plus 2a, and I'll be left with 4 plus a. So I now have x plus 2y times 4 plus a. This is what factor by grouping looks like. Let's try this one. and it says 2x squared plus 5x minus 4x minus 10. We have to be a little bit careful here because we have 2x squared plus 5x. I can factor out an x there, but in the negative 4x and the negative 10, I want to factor out a negative 2. I always want to think of this as plus here, and so whenever my first term here is negative, I always want to factor out a negative from here. When I do so, I will be left with x times 2x plus 5, and I'll have negative 2 times 2x plus 5, because remember, whenever I divide by a negative, it changes all my signs. The reason why I wanted to do this is so that my parentheses would look exactly the same, 2x plus 5. I can now factor out my set of parentheses and be left with 2x plus 5 times x minus 2. When we look at 8 AD plus 21 BC minus 6 BD minus 28 AC. Well, if I look at the first two sets of terms, 8 AD plus 21 BC, there's actually nothing I can factor out of those. There's no common factors. So what I'm going to do is I'm going to rearrange the terms a little bit so that I do have common factors. I'm going to set it to where I have 8 AD minus 6 BD and a negative 28 AC plus 21 BC. Now, if you look at my first two terms, 8 AD minus 6 BD, I can factor out a 2D, as I've done here, and I'll be left with 4A minus 3B. Looking at the negative 28 AC plus 21 BC, I can factor out a negative 7C and be left with 4A minus 3B. Notice my sets of parentheses are the same, which is the way I want them. I can factor out my common factor of 4A minus 3B, and I'll be left with 2D minus 2C. So I have 4A minus 3B times 2D minus 7C in the factored form. Again, I can use the FOIL or distributive properties to check my answer by multiplying them back together and see if I get what I started with. Factor by grouping is something that we use to factor polynomials where we have 4 terms. We also sometimes use it to factor trinomials once we replace the middle term with 2 terms. So you'll want to get used to the factor by grouping method. In the factor by grouping method, you always want to be able to say that your sets of parentheses are the same in the second step so that you can factor those out together. If you need help, please let one of us know.